Okay, first and foremost, we need to determine which molecule is our acid and which molecule is our base. This negative charge on the sulfur is a big red flag that this is our base because it's going to accept the proton in the form of a hydrogen to stabilize and make this neutral. So since this hydrogen is going to be donated to that sulfur, it is going to be our acid. This molecule is our acid. So now we need to draw the arrows indicating what's going to happen. So this negative charge is going to pull on this hydrogen, breaking this bond, leaving a lone pair on the nitrogen. And this gives us, let's see, let me draw these really quick. Okay, this gives us a formal charge of 0 on this sulfur, making it neutral, and we also have to make sure we conserve the negative charge throughout the entire equation, and we do this by adding that lone pair onto that nitrogen, creating a -1 formal charge. So now with a base, when it reacts with an acid, it creates a conjugate acid. So this would be our conjugate acid, and an acid, when it reacts with a base, gives us a conjugate base. So this is our conjugate base. Okay, and now we need to determine which is a weak base, weak acid, and strong base using ARIO. So we're going to look at the atom effect, and we're going to look at this, the acids. So we have a nitrogen here and a sulfur here. And if you look at the periodic table, the sulfur atom is further to the right on the periodic table, as well as a row down, making it larger. So it's more electronegative than nitrogen and larger, making it the strong acid. So this is going to be our strong acid, making this one weaker because nitrogen is less electronegative and smaller. So this is our weak acid. So a strong acid means it's less basic, so the base of the conjugate acid is going to be our weak base, and our weak acid means it's less acidic, so it's a stronger base, so this is going to be our strong base. Okay, now we need to determine which pKa is going to be higher. A weak acid has a higher pKa, so this molecule is going to have a higher pKa, and a stronger acid has a lower pKa. Now we need to determine or predict the equilibrium position. I'm going to predict that the equilibrium is going to be positioned to the left because our weak acid and our weak base are more stable than a strong acid and strong base, because strong acids dissociate more readily than a weak acid, and equilibrium always favors the more stable side. And because our equilibrium is shifted to the left, we're going to have a higher concentration of these molecules at the equilibrium.